We've all been there, right? Sitting in the dentist chair, they drape that heavy apron over you, and you get ready for an x-ray. It feels so routine. But it turns out, behind that simple procedure, there's a really fascinating story of risk, of innovation, and a serious quest to make things a whole lot safer.
So this scene, yeah, it probably looks pretty familiar. It's a panoramic dental x-ray, and it is an absolutely vital tool. It gives dentists that big picture view of our teeth and jaw. But while that machine is slowly spinning around your head, it's doing more than just taking a picture.
And that really gets to the heart of what we're talking about today. What if the very thing that's supposed to be protecting us could be completely reinvented? What if it could be safer, lighter, and maybe even better at its job?
To really get why this is so important, we have to talk about what's happening just below your chin during one of these scans. Because that X-ray beam, even though it's aimed at your jaw, it also passes right through one of the most sensitive organs in your entire body.
Yep, your thyroid. That little butterfly-shaped gland at the front of your neck, it's a total powerhouse. It controls your metabolism, growth, development, some seriously critical stuff, and it just so happens to be sitting directly in the line of fire during dental x-rays. Now here's where it gets a little concerning. The research is pretty clear on this. This quote right here, it kind of lays out the stakes. This isn't just some theoretical risk. It's a real, documented concern that has scientists thinking, okay, we need a much better way to protect people.
So the solution seems simple, right? Just throw on that heavy lead apron. I mean, that's been the standard for decades. But it turns out, our old trusty lead shield, well, it comes with its own set of problems. A very heavy burden, you might say.
Okay, so here's the deal with lead. First off, it's a toxic heavy metal. Not great. It's also ridiculously heavy and uncomfortable to wear. And then there's the environmental side of it. It's a nightmare to dispose of safely. I mean, come on, we can do better than this, right?
And this is where the cool part begins. Scientists basically said, let's invent something totally new. They wanted a material that could solve all of lead's problems. Something non-toxic, lightweight, comfortable, and, this is key, just as good or maybe even better at blocking radiation.
And what they came up with is actually, surprisingly simple. They started with this stuff called bismuth oxide. It's a dense but totally non-toxic powder. Then they mix it into a flexible medical-grade silicone rubber and added a simple hardener to help it set. The process itself is pretty slick. After they mix everything up, they hit it with ultrasonic vibrations. Think super, super high-frequency sound waves. This just makes sure all those tiny bismuth particles are spread out perfectly evenly. Then they pour it into a mold and just let it cure at room temperature. That's it.
And look at this. This is one of the biggest wins. Unlike that stiff, clunky lead apron, this new material is incredibly flexible. Just think about it. That means it can wrap more snugly and comfortably around your neck, giving you a better, more complete shield.
Okay, but having a cool idea is one thing. You've got to prove it actually works, right? So to see if this new shield was the real deal, it had to go head-to-head with the old lead standard in a super rigorous test.
So, how do you safely test something like radiation exposure? Well, you use one of these, a Rando Phantom. And this is not your average mannequin. No way. It's built with special materials that act just like human bone, tissue, and organs when they're hit with radiation. It lets scientists get incredibly precise measurements without putting anyone at risk.
So here's how the experiment went down. They set up 3 different tests. First, they zapped the Phantom with absolutely no shield, just to get a baseline for the maximum radiation dose. Then, they did it again with a standard lead shield. And finally, they tested their new creation, the bismuth silicone shield.
All right, this is the moment of truth. After all that work designing, mixing, and testing, it was finally time to look at the data. And what they found was, well, pretty incredible.
So what do you think? Did the new, flexible, non-toxic shield just hold its own against the old lead standard, or did it actually do better? The numbers here tell the whole story. Look at this. With no shield, the thyroid got a dose of about 387 units. The lead shield, it knocked that way down to about 38. That's great. But then look at the new composite shield. It cut the dose in half again, all the way down to just 19. Let's just put a single number on that. This new shield blocked an amazing 95.1% of the radiation from ever reaching the thyroid. That's not just a small improvement, that is a huge leap forward for patient safety. So the main takeaway here is pretty clear. The new lead-free shield isn't just a replacement, it's a genuine upgrade. It's lighter, it's non-toxic, it's more flexible, and it provides over 5% more protection than what we use now. It's a win-win-win. But there was one little wrinkle. Well, in science, it's never quite that easy, is it? The shield did its main job, blocking radiation, almost too well. And because of that, it created an unexpected problem for its other job, helping the dentist get a perfectly clear picture.
Check this out. The image on the left is a nice, clear X-ray with no shield. But look at the image on the right, taken with the new shield. You can see that big, dark shadow, what they call an artifact. The shield is so good at blocking X-rays that it actually blocks part of the image itself. And that could make it harder for a dentist to see what they need to see.
Now, it's really important to get this. This isn't a flaw in the new material. It's just a tricky problem with panoramic X-rays in general. Because the machine has to rotate all the way around your head, the shield is bound to get in the way of the beam at some point and cast that shadow.
And that leaves us with this really interesting final question. We've created a material that's safer for people, better for the environment, and more effective. And the search for lead-free shielding isn't just for dentistry, it's happening all over medicine, even for space travel. So the next big challenge for engineers is to tweak the design. Can they figure out a way to keep this amazing protection while getting rid of that shadow, giving us the absolute best of both worlds? The answer to that could really shape the future of safety for all of us.